So let's get going. People have started trigonometry, which means you're going to be able to answer my questions, which makes me excited. What is trigonometry? Tell me. Tell me in like a sentence. Write down your sentence that you think best describes what trigonometry is. I'm very curious to hear how you would define it. Okay, the relationship between side and angles. That's a really good start. That's a really, really good start. See if anyone feels like they can add to that definition. But I really like the words that are being used there. So let me write that down. Who thinks they can add to this? Trigonometry is a branch of mathematics that looks at relationships between sides and angles of, there we go, of triangles. Good. The concept of similar triangles, I really like that. We're going to talk about similar triangles now. The study of measurements, triangle, yes, and geometry, measures, exactly. Yes, hello. Let's have a look. Branch of mathematics that studies relationships between sides and angles. You guys are all on the right track. You are doing absolutely beautiful. Basically, trigonometry is looking at the relationship between sides and angles of triangles. Okay, now as we move through maths, so as we get into grade 11 or as we get into grade 12, we eventually start venturing out of triangles and we move into the Cartesian plane. So that's when the Cartesian plane is when we have our y-axis and our x-axis, and you'll have a point somewhere on that Cartesian plane. And the reason that we can use that Cartesian plane is because we are technically still making a right-angled triangle. And so wherever we can make a right-angled triangle, we can do trigonometry. And trigonometry is exactly what everyone is saying here. It's the relationship between sides. So we're able to find the lengths of sides and we're able to find the value of angles of different triangles if there is a right angle involved. Okay, so think about if you had a tricycle ever that has 3. So tri is talking about 3, or the rugby, what was that called? Tri-cup? Tri-rugby cup? Are there any sports people here who can help me? What was that rugby tournament that started with try? I feel like there was one. Am I alone in this?
Oh, I wish I could help, Ms. G, but I know nothing about sports either. I think they kick a ball and then.
I'm so certain that there was a rugby tournament that had try in it at some point.
Yeah. Maybe 3 times. Yeah, can I just interrupt for 1 second, guys? If you cannot hear ma'am, could I please ask you to check your speaker settings? You'll find 3 little dots at the bottom of your screen or on your computer, wherever it is. It's the Tri-Nations. There we go.
Tri-Nations, yes, because there were 3 nations. Thank you, guys.
And yes, and if you cannot, if that doesn't help, if you cannot check your speaker settings, please try leaving the class and coming back in. That might help reset your. I see a triceratops in the chat.
Triceratops, yes, maybe they had 3 different things on their backs, I don't know. But try is talking about 3, it's the number for 3. And then when we're talking with metry, we're talking about measurements. And I think someone actually wrote this in the chat for us. So when we're talking about 3, it's obviously a triangle, and measurements, we're looking at the measurements of triangles. Okay, Coco, I think Nomkita is having difficulties with audio. Do you mind sending them a private message?
Will do.
Thank you. Okay, so we're just going to take a quick journey through trigonometry for a second as to how we actually figured out trigonometry. Oh, thank you, Maha. Okay, so these over here, this is the Great Pyramid of Giza. It's in Egypt, and it's in the area of the Valley of the Kings, for anyone who's interested in anything to do with Egypt. And they took 10 to 20 years to build. It's made of 2.3 million blocks of limestone and granite. So you can imagine how long that would have taken. Like each block had to be put together to create these pyramids. Okay, and basically the first Greek mathematician, well, the first great Greek mathematician. There were other mathematicians, but they weren't sort of as famous. Just get rid of this writing here because it's in our way. He asked the Egyptian priests about the height of the Great Pyramid. So he wanted to know how tall this pyramid was. But the priests felt that the pyramids were something sacred. And so they weren't allowed to talk about anything to do with them. Like they weren't allowed to know any facts. And so the priests refused to tell him. I think they just didn't know, to be honest. But I don't know. This is in ancient times, guys. So Thales, I'm not sure how you say his name properly. He used the shadow of a stake in the ground to estimate the height. So basically what he assumed was that if we had a sun chilling up over here, this is our happy sun. Okay, yay, he's in a good mood because it's summer. So Thales assumed that the rays of the sun were all going to be parallel to each other. Okay, so those of you who are doing geometry at the moment, and if anyone remembers geometry from last year, if lines are parallel, then we know that that angle and that angle would be the same as each other, okay, because they would be corresponding angles. And this line over here is perpendicular to the ground, and this line is perpendicular to the ground. And so he's created a triangle which is similar to the triangle that is of the pyramid, but he knows the things in the small triangle that he's created. What does it mean if I say that triangles are similar to each other? Can someone give me an answer for that? What does it mean if triangles are similar? So congruent would mean that they are exactly the same in every way. So these aren't congruent because otherwise he would be dealing with a very, very, very big triangle. So Kamba, it's congruent would definitely have the same lengths. Good, Rangani, they have the same angles as each other. So similar triangles have the same angles, but they're different sizes. So if you imagine, you know, when you sometimes put a picture on a computer or on your phone and you drag it to make it bigger or smaller, the angles of the picture stay exactly the same and you're just making it bigger or smaller. So they are similar to each other, but they're not exactly the same. So congruent, exactly the same, similar, same angles, different sizes. So he created these similar triangles. And so he knew that if this was, let's say this was, let's make it nice and easy. Let's say this was 220 meters. Okay, because that's something he would be able to measure because that's a distance on the ground. We know that this is 90 degrees. We know that this angle is the same as that angle. We know that that's 90 degrees. We know that this angle is the same as that one because there are three angles in a triangle and they are similar triangles. So if his triangle over here, if that distance was 2 meters, and this distance of the big pyramid triangle was 220 meters. Think about what I would have to multiply 2 by to get to 220. And then if this was 1 meter high, can you tell me what the height of my pyramid is? So think that through and then tell me what the height of my pyramid would be. Let's make it even a little bit tougher. Let's say that this is 3 meters. But Angel, you're on the right track. Because your answer was right for what I asked originally. Good, 2 times 110 would give me 220. Good, guys. So now what would be the height of my pyramid? Nice. Nice job, guys. So if I multiplied my 3 meters by 110, I would get 330 meters. Now you might be sitting there thinking, this is bizarre. Why are you talking to me about Egypt and pyramids when we're supposed to be doing maths and trigonometry? Because this is trigonometry. It's just a simplified version of it. This is how trigonometry started, was when we tried to figure out a length of something using the idea of angles. And so this idea of similar triangles came into the world. And this is how we started formulating the things that we use now every day in trigonometry, all came from this idea of similar triangles. So actually, if you understand similar triangles, you understand trigonometry. I see I have a question. Ask away. Nope. Okay. Okay, so just before we start panicking about the different things that we're going to learn, one thing is we are going to be talking about a whole lot of different kinds of angles when we're talking about trigonometry, because we're in deep Greek mathematics now. Who thinks they can tell me, especially those of you who've already started trig or done trig in class, some of the angles that we use in trigonometry? So some of the names of the angles that we use. My hint to you is to think of like wolf packs. Ah, beta. I see beta. Good. Special angles is actually something we do. Alpha. Good. And theta. Nice. Okay. So, for those of you who have not seen trig yet, these may seem scary, but they're not scary. Please don't panic. They are just our Greek letters, and we use them to explain angles when we're dealing with trig. So, if we're drawing like a triangle, for example, in normal geometry, we would have like X or Y, and we'd say try and find X, try and find Y. And now instead of saying that, we will say try and find theta or try and find alpha. So these become really important things for us to know. So make sure you know what those words are and what their symbols are. Maybe jot them down somewhere so you can see. But beta is like a bee with a long tail. Alpha is like a little fish, and theta is an O with a little hat. I like to think of it as like a little person if you had eyes in there. Don't you have a little person staring at you? So we've got beta, alpha, and theta. So omega is a Greek letter, but it's not one that we use in trig. I don't know why. But if anyone's watched Lock and Key on Netflix, you would see the omega symbol. Looks like that. That's omega, but we don't use it in trig. Okay, so those are the angles that we commonly use in trig. And then we have 3 words. Well, we have more than 3 words that we use often. So I saw lots of people were saying the words right angles, which is absolutely right. So we definitely use the term right angle a lot. How many degrees is right angled? Is a right angle? 90. Thank you, guys. Thank you. So it's 90 degrees. It means it's perpendicular. And if we're wanting to show it with the symbol, it's that upside down T. Okay, so the right angle we talk about a lot. I'm seeing lots of people saying sine, cos, and tan, which is definitely something, but we're going to talk about them just now. They're called trig ratios, but we will talk about them. But there's 3 other words, which sounds bizarre to say that they're words that we use. But for those of you who have done trig already, my hint to you is that they start with an O, an A, and an H. See if that helps. I think what you're wanting to say is SOH CAH TOA. We're going to get to there now. Great. Hypotenuse, opposite, and adjacent. Absolutely. Hypotenuse. Opposite and adjacent. Okay, so let's just quickly go through what these words mean before we start moving into triangles. Who can tell me what a hypotenuse is? Who can tell me what a hypotenuse is? And it's not a hippopotamus. It's not an animal. Good, it's alongside of what? It's the longest side of a right-angled triangle. So I saw lots of people were very close to that, but getting there. So it's the longest side of a right-angled triangle. Okay, what I mean by that is if I have a right angle triangle, it's always going to be the side which is opposite the right angle. That is always going to be my hypotenuse. Okay, so when we start moving things around, some of our other things are going to change. The opposite and adjacent are going to change, but the hypotenuse is always the hypotenuse. Mohau, do you have a question or were you going to answer something?
Ma'am, I was wondering, ma'am, like isn't like the right angle triangle the only one with a long side?
No. So for example, I could have let me draw an obtuse triangle. So that's an obtuse triangle, and in that would be my longest side in an obtuse triangle.
Oh.
Do you see what I mean? But that longest side is not a hypotenuse because it's not in a right angle.
Yes, ma'am. So when I say the longest side of a triangle, it obviously states the right angled one, right?
Yeah, exactly. You have to say of a right angle.
Oh, okay. Thank you, ma'am.
No problem. Okay, so that's our hypotenuse. Hypotenuse is the longest side of a triangle. Then we have opposites. Now I want you to think just when you think of opposite, if someone is opposite to you, they are literally opposite, you would be looking at them. Okay, so they are opposite you. And then, so just think about what opposite is. It is just what it is. And adjacent is a word we spoke about when we spoke about geometry last year. What does adjacent mean? What's a nice, easy word for adjacent? Good. Next to. Excellent. Okay. So hypotenuse is the longest side of a right angle triangle. Opposite is when something is opposite you, and then adjacent means it's next to. Okay. So these words are words that we're going to be using a lot over the next couple of weeks. This trig course is going to be 4 weeks, so we're going to have 8 lessons, and we're going to be using all of these words lots. So make sure that you're feeling comfortable with them. Okay, so let's quickly zoom through these and then we're going to put them in triangles. We've got angles, beta, alpha, and theta. The one we are going to use the most often in trig is theta. Okay, and then words, hypotenuse, opposite, adjacent. Good. Nice. Okay, so let's try and check these on some triangles. Now, when we have triangles, we need to start bringing in our trig ratios. Sorry. Oh, almost going down to a puzzle, guys. My screen's taken a life of its own. Okay, so let's have a look at this. At the moment, we're just going to try and label this triangle. So we're not going to bring in sine, cos, and tan yet. We're just going to try and label it. So we're going to try and label it with O, which is going to be our opposite. Okay, so O is for opposite. I'm just writing it while we're learning. Then we're going to have H, which is hypotenuse. And we're going to have A, which is adjacent. Okay, so I'm going to help you with these two, and then I'm going to give you a couple to work through them. So we're not going to bring in cos, sine, and tan just yet. We're going to get into them just now. So what I said earlier is the hypotenuse is always the hypotenuse, and the opposites and the adjacent depend on which angle we are talking about. Okay, so if this is my right angle, then this long side here, so the side that is opposite my right angle, that is always going to be our hypotenuse. Okay, I'm not even going to write hypotenuse, I'm just going to write H. That is our hypotenuse. Now, I'm going to put our angle, so I'm going to put our theta over there. And we need to think about, in relation to where theta is, which side is going to be opposite and which side is going to be adjacent. So if this angle is theta, then if I was going across, so that's talking about I'm looking opposite, then that's going to be O. And remember, adjacent meant next to or touching. And so this side over here is going to be A. Okay, so and that changes depending on where theta is. So our hypotenuse is always going to be our hypotenuse, and then our A and O are going to be dependent on wherever theta is. So let's try and put theta in a different position. So I'm going to write A, B, C. That's my triangle. This is my right angle. And I'm going to ask you which side, so AB, AC, or BC, is my hypotenuse. Which is my hypotenuse? Good. Okay. So we don't have to have an angle even to know our hypotenuse is. Our hypotenuse is always our hypotenuse. And now I'm going to put theta up there. And I want to know if theta is by B, then which side is my adjacent? Okay, so now remember, adjacent means next to. So we have to think, well, this side over here, that's really far away, but BC is right next to it. So my adjacent side is going to be the one where that theta is touching. Okay, so it's going to be BC. And if that one's my adjacent and my other one is my hypotenuse, then obviously AC is going to be my opposite because it is the one that is opposite my angle. So we have hypotenuse, opposite, and adjacent. Does anyone have any questions about this? We're just going to do a quick questions just based on this. We're not going to bring in tan, sin, and cos yet. So are we all still okay? Okay. All right. I'm going to put some labels on here. And you don't have to do all of these. If you're struggling, I want you to just focus on a couple. And if you're finding them really easy, then I want you to try and see how many of them you can get done. Okay. Basically, what I'd like you to do is if it's possible for you, if you've got a piece of paper nearby, just quickly jot down these little triangles. And I want you to fill in the O's, the A's, and the H's. So for example, for question 1, I can see this is my H. This is the angle I care about, which means this is my O and this is my A. So I would like you to fill in the O's, A's, and H's of the rest of these triangles. And then I'm going to put the answers up on the board. But I'll give you a couple of minutes to do it. And then after this, I've got a really, really hard puzzle for you guys to do. The grade 9s couldn't solve it. Fancy, how can I help?
Hi, ma'am. I was asking if you could please go up to the first one. I didn't get the last triangle. Thank you.
You're welcome. Onaka, that's excellent. AC is definitely H in question 2. Good. Daniel, hi, how can I help?
Ooh, you're going to have to unmute, sir. We can't hear you. Remember to click unmute first.
I don't know. I don't know. Is hypotenuse or what?
Oh,
Yeah, so the H is hypotenuse. Let me write it a little bit bigger. Hypotenuse. It's just a fancy word for saying the longest side of a right angle triangle. So the side that's opposite our right angle.
Okay, thank you.
You're welcome.
Thank you.
Bungasiwe, can I help? Can I do question 2 and 3? Am I rushing if I do question 2 and 3? Has everyone done 2 and 3?
And then we've got people in the chat done with all of them. So.
Oh, okay.
Oh, yeah.
Excellent. Then let's go. Uyabongo, can I help? Do you have a question?
No, member does a mistake.
Okay, no problem. Okay, let's go through these in those style zippy zips. Let's go through them. So 2, AC is going to be our hypotenuse. AB is going to be our adjacent, and BC is going to be our opposite. Now, as we go through these, I want you to figure out how many you get all right. So I gave you the first one. So the most you can get here is 5 out of 5. Let's see who can get 5 out of 5. But keep track. Okay. In number 3, AC is going to be our hypotenuse. AB is going to be our adjacent, and BC is going to be our opposite. In number 4, AC is going to be our hypotenuse. BC is going to be our adjacent, and AB is going to be our opposite. Number 5, AC is our hypotenuse, BC is our adjacent, and AB is our opposite. Doubted myself there for a second. In question 6, our hypotenuse, our adjacent, and our opposite. So I want to know in the chat what you got, 1, 2, 3, 4, or 5 out of 5. Let me know how this went. Oh, 5. Nice. 4 out of 5, 3 out of 5. Ooh.
Sure, so many 5.
No. Those of you who got the 3s, is it because you mixed up your A's and your H's? Because that often happens.
Yeah.
Lots of people make the mistake of mixing these two around because they're both touching the angle. So my advice is always put your H in first. So always put in your hypotenuse because your hypotenuse is constant. And then it's not confusing to know where your A is.
Okay. Tomani says, may you please explain number 6 again, please?
Absolutely. So number 6. So the first thing we would look at is here is our right angle. And so our side that's opposite the right angle, that's going to be our hypotenuse. So that's my H. Then this is the angle that I'm caring about. And so the side that is right next to that angle is my adjacent side. And then the side that is opposite to that angle is going to be my opposite. Okay. Cool. Nice job, guys. Okay. So those of you who are new, who don't know my lessons, you are now going to have your brain broken apart a little bit. What we like to do midway through our lesson is we call it a little brain break, but it's actually, it does break your brain. So maybe we can call it a brain break. I always like to give you a puzzle to make you think a little bit outside the box. It has nothing to do with what we are actually doing. So don't panic if you feel lost in it. It's just something different to try and think about. Okay. Normally I try and give you some kind of picture to think about what it is. I'm warning you that this week's one is really hard. So I'm going to give you a time limit. I'm going to give you until it says 1840 on my clock. And if you don't get it, then I'm going to bring it back on Thursday and see if anyone can figure it out on Thursday. So if you have the answer, I'm going to help you a little bit because I know for a lot of you it's your first lesson. So you may not have seen things like this before. Basically, I'm wanting to find out what this final answer is over here. So if I'm looking at this first line, I can see I've got 3 crowns. The crowns are all the same as each other, so they must all be the same, which means each crown must be 8 because they have to equal 24. Okay, so that means that that crown there is 8. But my warning to those of you who are trying to zoom through this is that this crown has got a blue ruby and this crown has got a red ruby. I'm just going to put that out there. And this ring has got a blue ruby and this ring has got a red ruby. So, you know, let's just see. But once you have a number, you can check your number in the chat and I'll tell you if you're right or wrong. Wongakile, do you have a question? You're already from the lies. No, 14 and 42 is not right. No. 28, 56. No, no. 33, no. The ring with the blue diamond is 7. Yes, I'll give you that. 53, no. No to 24, no to 60. You got 2 minutes, guys, and then I'm calling time on this one. No to 44, no to 32, no to 63, no to 10. No. No, not 50 either. No. It is a tough one. It's not 38, it's not 12, not 30.
Man, I'm trying to figure out if like just the blue diamond and the red diamond sitting together, is that a multiplication or is that an addition? I don't, so difficult. Okay.
It's an addition, if that helps.
Okay.
You got 1 minute left, guys. No one in the chat's right yet.
Yes, Romla, I'm confused too. I'm trying.
No. None of these answers are right. I'm not going to read them all out because you'll get so tired of me saying them, but I'm going to tell you they're not there. You stand with 31. I've told you 31's not right. Like I'm standing with this wrong answer. No. Oh, your time's running. There's some who are very close, but you're not right. And time is done. So what I recommend you do is you take a screenshot or take a photo, depending on what device you're working on, because I'm going to bring it back on Thursday. Okay. Okay. Let's jump back into maths. How exciting. Okay. So trigonomic ratios, now that everyone's brains are sufficiently broken. Trigonometric ratios, that's what everyone was saying just now. That was when they were saying sine, cos, and tan, which is absolutely right. So we've got sine, which I know we write it as sin, but we say sine because the full name for it actually has an E. So we say sine. Oh, goodness. And then we have cos, which is actually, its full name is cosine, but we say cos. And then we have tan, which is our third one. And its full name is tangent. And we use those letters that we just spoke about to think about what these different ratios mean. And remember, a ratio is just a fancy word for meaning fraction or decimal. So sine is opposite over hypotenuse. It's not 54, fancy, I'm sorry. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. And if you're sitting there thinking, I have no idea how I'm ever going to remember this, we have a little riddle. So we say SOH CAH TOA. That's how we remember our trig ratios. SOH CAH TOA, SOH CAH TOA. So all say it to yourselves at least 4 times. SOH CAH TOA, SOH CAH TOA, SOH CAH TOA. That's how we remember trig. And you'll have people still in matric who are still saying SOH CAH TOA and writing it out on their page. Sometimes when I'm really tired and I can't think, I still say SOH CAH TOA. So SOH CAH TOA will stay with you for a long time. Make sure it is ingrained in your brain. I want you to go to sleep saying these 3 words. I want you to go to sleep humming SOH CAH TOA, SOH CAH TOA, so that you never, ever, ever forget. Okay, so sine opposite over hypotenuse, cos adjacent over hypotenuse, and tan is opposite over adjacent. So what I mean by that is when we start bringing in angles. So for example, I'm going to have my theta over there. I'm going to label this triangle ABC, and I'm going to put my little right angle over there. If I want to know, I'll talk you through this triangle and then I'll let you try the second one. Okay. If I want to know what, let me write it up here so you can see everything, sine of theta is. We need to now think about what our different sides are. And that was why I spent so much time making sure everyone's comfortable with labeling your sides. So the first thing we want to do is we want to label what our different sides are. We always start with our hypotenuse. And our hypotenuse is our longest side of the triangle. So we know that that's hypotenuse. Then we think, okay, the other side that is touching our angle, that is adjacent. And then the side that is opposite that angle is going to be opposite. So we have hypotenuse, adjacent, and opposite. Now, if I'm wanting to write out the ratio of sine theta, I want to write out which side is my opposite over which side is my hypotenuse. Okay, so sine theta in this situation would be BC, because that's my opposite, over AB, because that's my hypotenuse. And as we start getting into more tricky trig, and as we start figuring different things out, we're going to be learning how to find the angles and how to find the sides. But at the moment, we just want to figure out how to write the ratio. Okay, so next one, if I'm wanting, I'm going to make this alpha there. Okay, if I'm wanting to know what tan alpha is. Oh no, let me not do that just yet. Let me not be that nasty. Okay, if I want to know what tan theta is, what would that be as a fraction? What over what? Let's have a look. What over what would be tan theta? Good. Opposite over adjacent, and my opposite is BC, and my adjacent is AC. Beautiful, guys. Okay, and let's do our last one here. Let's do cos of theta. So cos of theta is adjacent over hypotenuse. So how would I write that as a fraction for cos of theta? Nice. Good job. Good. Okay. We're going to move into this triangle on the right. I'm going to label it A, B, C. I'm making that my right angle. And I'm going to make this up here alpha. And I want to know what sine alpha is. I want to know what cos alpha is. And I want to know what tan alpha is. So your first job is to make sure you have that triangle somewhere in front of you. And I want you to fill in your O, A, and H. And remember, it's according to where the angle is. So I want you to fill in your O, A, and H. Always start with your hypotenuse. And once you've done that, then I want you to think about what these fractions are going to be. So what is sine alpha going to be? What is cos alpha going to be? What is tan alpha going to be? And when you're feeling good with your answers, then just pop them in the chat for me and we can go through it and we can see if anyone can get 3 out of 3 here. So just keep going. You're doing really well, guys. Especially if this is your first week back at school. I know the first week, it's hard. Okay. All right, so the first thing I'm going to do is I'm going to put in my ratios. I'm just going to use a different color here. So I know that that is my hypotenuse. I know that that is my adjacent and that is my opposite. So even if you got that far, I'm really proud of you, especially if you haven't done trig before today. Okay, sine is going to be opposite over hypotenuse, which means it's going to be AC over AB. Cos is going to be adjacent over hypotenuse, so BC over AB. And then tan is opposite over adjacent, which is going to be AC over BC. Who landed up getting 3 out of 3? Oh, you got 1 out of 3 with 2 out of 3. Kelly Angel, well done. Ria, nice. Unako, Uyabongwa, well done, guys. Yes, stoked. Canva, yes. Good. We're getting there. Awesome. Remember, with maths, it's all about building. So if we don't have our foundations strong, we can't build on them. So we need to make sure we know all of this super well, so that when we build up, we feel good and confident, like a nice warm maths hug. Good. Okay, so let's try and bring in a question. So I've taken these questions from exams. So, and they're all stuff that we're able to do at the moment. So in the diagram, we've got triangle ABC, and it is a right angle triangle. So there's our right angle down here. Oh, sorry. There's our right angle there. And there's another triangle, which is ADC. It is a right angle there. Okay. They've also told us that angle B is theta. So now the first question is, obviously, I'm just going to help you out because I know we've just started trig today. So if that one on the one side is 90, then the other one is also going to be 90. Okay. The first question is saying, write down 3 possible ratios. So that's just saying a fancy word for writing the fractions with the sides for tan theta. Now, everyone should be able to at least get 1. 2, I'll be very happy if you can get 2. And if anyone can find the 3rd one, I'll be really, really impressed. But I'm going to give you a little bit of time to try and sit with this and try and figure it out. And then I'm going to help you. I'm going to walk you through it. So if you're feeling lost, don't panic. I promise I will walk you through it. But I want you to sort of try and engage with it a bit first by yourselves.
I think Cyrilo might have a question.
How can I help?
Hello.
Hi.
Can you please repeat the question?
So the question that I'm asking is, I'm wanting to know 3 possible ratios, so 3 fractions. So it was one side over one side for tan theta. So this is where my theta is. And I'm wanting to know 3 different possible fractions of how I could write it.
Okay, thank you.
Sure. I'm just going to give it a little bit more time and then I'm going to take you out of your misery. So everyone should be able to find 1. Some of you will be able to find 2. And I'll be very, very impressed for those of you who can find 3. Don't worry, Tiama, I'm not going to rush you. Take your time.
Hello, admin. How can we help?
Please repeat what does it mean that we must write 3 possible ratios?
So the ratios are the things like we've been talking about. So where we have a triangle, if this was A, B, C, and if this was theta, and that was O, A, and H. If I wanted sine theta, then one ratio would be opposite, so AB over hypotenuse, which would be AC. That would be one of my ratios. So this picture, because there are 3 different triangles where there are right angles, there are 3 different ways I could write tan theta.
Thank you.
Sure. Yeah, all of the lessons will be on the Watobe website. I think it just takes between 24 and 48 hours for them to go up, as far as I remember.
Whoa, Onako. Onako found all three.
Okay. Can I go through them yet, guys? All right, let's go through the first one first. First one, so this is the one that I felt everyone would be somewhat okay to do with, is we're looking at this big triangle over here, which is my right angle triangle. And we are wanting to figure out our opposite, our adjacent, and our hypotenuse dealing with that big triangle. Okay, so with this big triangle, this would be my hypotenuse, this would be my adjacent, and that would be my opposite. So my first ratio for tan, if I was looking at tan theta, would be opposite, which is AC, over adjacent, which is BC. Who got that one correct? Who got the first one? Who got AC over BC? Let me know. Good. Yes. I like it. Great energy tonight, guys. Good job. Okay, so that's our first one. All right, second one. Ooh. We're going to look at this triangle over here. Now, I remember let's just, I like my colors matching, guys. I can't help it. Okay, so now that's my right angle over there. This is still my theta, but now this is my hypotenuse because that's the side that is opposite my right angle. Okay, this is my adjacent and that is my opposite. So that's the first step, is to figure out which triangle we are and label it correctly. And in that case, my tan theta is going to be DC over DB. Opposite over adjacent, DC over DB. Who got number 2 correct? Number. Okay, those of you who did not see it, do see it now though. That's also what is important. Good. Okay. Okay, so those were the two, like the first one was the easiest one, the second one was like a little bit harder, now the third one is the hardest one. So this is the one that I'm going to be like super impressed if anyone ended up finding this one. So let's just talk it through. This is going to be the last thing we talk about this evening, and then I'm going to let you go and have a beautiful evening. For those of you who are new, I only sing because someone told me I had a terrible voice last year. So now I just do it to torture you all. Okay, so we have this right angle here, and then we've got this theta over here. And then we have this third angle of the triangle. So I just want you to keep that in mind. So I'm actually just going to highlight this small triangle. And you're going to see you have a right angle, a theta, and then you've got this little dot here. Okay. And now I want you to think about this triangle here. Now, in that big triangle, that green triangle, okay, you've got a right angle, you've got a theta, so it's the same as that purple triangle. And remember, if there's 3 angles of a triangle, if 2 of the angles are the same, then the third one has to be the same. So if anyone's done similarity yet, then you would have known that from class. But just think about if you had a triangle that was 90 and 40, and another triangle that was 90 and 40, then obviously those two both have to be 50 because triangles have to equal 180 degrees. Okay, so now if in this green triangle, if I have a 90 degree and a theta, then that means that this angle over here must also be that dot, okay, which means that it's the same as my other one. Okay, so then we move one step further into this smaller triangle. So now I'm working in this blue triangle over here. And now I've got a 90-degree and a dot, which means that this third angle is going to be theta. So we're using this idea of similar triangles to move our way from one triangle to another. Now in this blue triangle, so in this small triangle over here, where theta is, this would be opposite, this would be hypotenuse, and this would be adjacent, which means in that small blue triangle, my tan theta is going to be AD over, where am I? DC. And that is my third one. Now my final question is, who managed to find that blue triangle and get that third ratio? Did anyone manage to find it? Did anyone find this dude? Neil, well done. Mananga, well done, guys. I'm really proud of you if you got that blue one. That was a hard question. That was like an extension question. So I'm really chuffed if you got there. Okay, my goal is I hope that everyone felt okay with finding this first one, especially if you haven't done trig. If you just were able to get that pink one, then I'm really happy. If you've done a little bit of trig and you were making your way, I'll be really stoked if you got the purple, and if you got the blue, then I'm just up to the moon. And that, guys, is where we are going to call it an evening. So once you are ready, you can just sign yourselves out, and I will see you all on Thursday. But thanks for coming tonight. I hope you had a good lesson.
Thank you, ma'am, for the lesson.
You're welcome, guys. Bye, everyone.
Thank you, guys.
Bye, ma'am.
Bye.
Bye, ma'am.
Bye, everyone.
Bye, ma'am.
Have a lovely